Hi, social studies students. I'm Ms. Strickler. Mr. Harris and I today are going to be taking you through the Mapping Earth at Home notes. You received a packet in class this week, last time we saw you, so you'll need to get that out and have it in front of you. You will also need a pen, pencil, or a highlighter, depending on the kind of notes you received. Some of you received notes that look like this, that have some fill in the blank areas for you to follow along with this PowerPoint. Others have received notes where things are written in, and you will be highlighting along with me and Mr. Harris as we go over the slides. So depending on your kind of notes, grab the writing instrument that you will need. And also, just so you know, if you lost your copy that we gave you in class or you were absent that day, you may print another copy on Schoology for yourself. Things to remember. As you watch this video, you can pause at any time. If we're going too quickly and you're trying to keep up, watching and writing down what you need to put in your notes, pause. Just hit the pause button so you can keep up. Words on the slides that are underlined in color, I think most of them are written in yellow. They match the blank spaces in your notes. So if you have a blank space, the yellow word will be written in that spot. If you have all the words written in, you will highlight the yellow word. Also, when this video pauses, Mr. Harris and I may ask you a question. It will appear in the sidebar. You'll type in your question or select the best multiple choice answer in order to move on. So let's get started. Our learning objectives for today: describe the coordinate system we use to map locations on Earth and identify important circles of latitude and lines of longitude. Also, calculate latitude using the location of Polaris. I'm going to be taking you through pages 1, 2, and 3 in your packets, and then Mr. Harris will take over and take you through pages 4 and 5 and the wrap-up discussion section. So here we go, mapping Earth. We often illustrate what Earth looks like with maps. A map is a diagram or representation of an area of land or water that shows the physical features of that area. So if I fill in the blank notes, I'm going to take my pen or pencil, and I see that the word diagram is underlined in yellow. So I'm going to write diagram in the first blank and then physical features in the next two blanks on my first bullet point, like I did there. If I have notes that need to be highlighted, I'm going to take my highlighter, find diagram and physical features, and highlight the important information that I need for my notes. All right, that's the last time I'm going to do that, but please follow along with me and fill in your notes. Next, we describe locations on Earth using a coordinate system. When we need to find exact locations of cities or places, we will use the coordinate system, much like you've probably maybe seen in math. This coordinate system describes any location on Earth using two numbers. One number will represent a north-south position on Earth, and the other number represents an east-west position. All right, so you should have your notes filled in for the first page. So now I'm flipping over to page 2, where we are going to start talking about latitude, lines of latitude. Latitude is the coordinate that tells us the north-south position. Lines of latitude run horizontally around the Earth. So here is my Earth. Ms. Strickler forgot to buy an extra beach ball for this presentation, so I'm just going to use a ball. Lines of latitude, again, they run horizontally, meaning this direction around Earth. Latitude is measured in degrees. The equator splits our Earth into two halves. So as I finish this line, This is our equator that I'm drawing on this ball here. The equator is the imaginary line that runs around the center of the Earth at 0 degrees. I'm going to label this equator, so don't forget. The top half of Earth is called the northern hemisphere. So anything above the line, the equator, that imaginary line, is the northern hemisphere. The bottom half of Earth is the southern hemisphere. Anything below that line. Now, where do you think we live? We are in North America over here. So what hemisphere are we in? Lines of latitude north of the equator are measured in degrees north. So any location above the equator all the way to the North Pole are measured in degrees north. Here's the little symbol that you will see next to the number, 0 degrees north. Lines of latitude south of the equator are measured in degrees south. You will see those numbers with a degree S next to them. Now, on your notes, before I talk about it, you have a chart. Other lines of latitude. So there are 5 significant circles of latitudes on maps of Earth. You're going to write them all in. And then there are blanks in the importance or significance of those lines that we will go over next. So first, I want you to write in. First one's been done for you. We have the equator. Number 2 is the Arctic Circle. Number 3 is the Antarctic Circle. Number 4, we have the Tropic of Cancer. And number 5, the Tropic of Capricorn. Please write all of those in your charts, 1 through 5. And then we will talk about their importance. Now, the equator has been done for you. The equator runs at 0 degrees latitude. We already discussed that the importance of it is it divides the Earth in half in between the northern hemisphere and the southern hemisphere. Number 2, the Arctic Circle. So again, you are filling in the blanks on the importance or significance of the line on this side. So the Arctic Circle runs at a latitude of approximately 66 degrees north. It is the circle that goes around the North Pole. You can see it here. Locations north of the Arctic Circle experience a 24 hours of daylight at summer solstice and 24 hours of darkness at winter solstice. So, for example, if anyone has ever been to Alaska, during the summer solstice, which happens in June, they experience 24 hours of daylight. And during the winter solstice that happens in December, they experience 24 hours of darkness. Number 3, the Antarctic Circle runs at a latitude of approximately 66 degrees south. The Antarctic Circle is the imaginary line that runs around Antarctica. Locations south of the Antarctic Circle experience 24 hours of darkness at summer solstice, opposite of the Arctic Circle, and 24 hours of daylight at winter solstice. Moving on to number 4 and 5 in your chart. 4, the Tropic of Cancer. 5, the Tropic of Capricorn. The Tropic of Cancer runs at a latitude of 23.5 degrees north. During the summer solstice, the sun appears directly overhead at locations along our Tropic of Cancer. And number 5, our Tropic of Capricorn runs at a latitude of 23.5 degrees south. It is located in the southern hemisphere. The sun appears directly overhead at locations along the Tropic of Capricorn at winter solstice. So if you look on this chart here, during the summer solstice on this side, If you find this line, the Tropic of Cancer, at summer solstice, which happens in June, midway through June, it's also known as the longest day of the year. The sun will appear directly overhead as the Earth rotates around the sun. And during winter solstice, the Earth has rotated, so the Tropic of Capricorn has the sun directly overhead. Moving on to longitude. Now we are going to talk about lines of longitude. I am on page 3 of your notes. Longitude is the coordinate that specifies the east-west position. Lines of longitude run vertically around the Earth from the North to the South Pole. So here's my equator. Our lines of longitude run vertically from the North Pole all the way to the South Pole. So here's my line of longitude. Lines of longitude range from 0 degrees to 180 degrees east and west. These lines of longitude measure locations east and west on Earth. The prime meridian, which we'll call this line here, is the line of longitude at 0 degrees. The prime meridian passes through Greenwich, England. So here is my prime meridian. All right, so prime meridian here. It's a little crooked, that's okay. But did you know there's also something called an anti-meridian? The anti-meridian runs on the opposite side of Earth. So here's the anti-meridian. The anti-meridian is the line of longitude at 180 degrees. There goes my anti-meridian, and we're going to connect at the bottom at the South Pole. The anti-meridian is important because it's used as a basis for the international date line. This line marks the change of one day to the next. Now, we all know from science that the Earth rotates. In order to make one full rotation from the prime meridian all the way around, takes 24 hours as we're rotating around. This anti-meridian, which is on the other side of Earth, marks when we have one day to the next. And here's a picture of the Earth where we have daylight on one side and the Earth turning into night on the other. The prime meridian and anti-meridian form a circle around Earth. This splits Earth into two halves. The west half is called the Western Hemisphere, and the east half is called the Eastern Hemisphere. Now find North America again on this map, and what hemisphere are we located in? Here's North America, so we are in the Western Hemisphere. Lines of longitude west of the prime meridian to the anti-meridian are measured in degrees west. They have the symbol, the degrees W next to them. Lines of longitude east of the prime meridian to the anti-meridian are measured in degrees east. And you can see the lines. Once you filled all this in on the next page, you have a nice little globe with all of the lines measured here that you can take note of. All right, so that's all for me. You guys should have completed pages 1, 2, and 3 by now. And now Mr. Harris is going to talk to you guys about celestial navigation in the star Polaris.